Rational Unified Process. Today, we are going to explore the rational unified process. We'll begin with a brief introduction to the rational unified process. What is and what is significant in the software engineer. Then we can see the phases, the core disciplines, their strengths and the weaknesses. Finally, we'll review some recommendations for applying RUP to cyber physical system and conclude with a brief summary of the key points. So let's begin. The Rational Unified Process is originated at Rational Software Corporation in the mid-90s, when Jacobson, Bosch, and Rumbarel unified their earliest methodologies into a single process model. This integration led to the Unified Modeling Language (UML) and to RUP as a guiding framework. Following IBM's acquisition of the Rational software in 2003, RUP became part of IBM's software suite, continually refined to integrate modern project management, business modeling, and configuration management practices. So, what is RUP? According to Crutzen, the Rational Unified Process is a software engineered process that provides a disciplined approach to assigning tasks and responsibilities with a development organization. What is its goal? The goal ensure the production of high quality software that meets the needs of the end users within a predictable schedule and budget. Some of the benefits are the adaptability and the maintenance for ABM. Some of the tools that you can use are IBM Rational Rows, StarUML, or Lucidchart. RUP is a process product, distributed and updated like software itself, and flexible framework that organization can tailor. It combines multiple modern practices into one coherent process. It is use case driven, meaning user goals guide requirements and designs. So, now we're going to describe RUP from the three perspectives: the dynamic perspective, static perspective, and the practice perspective. For the dynamic view of the RUP, describe how development unfolds over the time and the evolution from concept to deployment. Let's explore the four main phases of this process. For the inception phase, the main goal is to establish a clear business case for the system. If the business value or impact is minimal, the project may be cancelled after this phase. For the elaboration phase, its objective is to develop a deeper understanding of the problem domain and to establish the architectural foundation of the system. For the construction phase, this phase is where most of the development effort takes place. It includes system, design, programming, and continuous testing. For the transition phase, the final phase of the RUP focuses on moving the system from the development environment to the real world user environment. In this phase, the system is tested in real conditions. Each phase contains plan interaction ending with clear milestone that validates the progress. These control iteration ensure risk reduction, early feedback, and adaptive planning through the life cycles. So, for the static view, explain RUP's internal structure, which explain the who, what, and how. It defines roles, activities, artifacts, and workflows. RUP includes 9 core disciplines that are business modeling, requirements, analysis and design, implementation, testing, and deployment. They conform the core process discipline. Also, we have in these 9 the core supporting disciplines that are configuration and change management, project management, and environment. It, those three are still static perspective. it comes for the nine. Configuration. This modular composition forms an open framework that your organization can configure. Together, these nine disciplines define how the RUP structures and organize software development activities. The RUP also integrates the main best practice in software engineering defined by Bush and others, like develop software iteratively, manage requirements systematically, use component-based architectures, visualize model software with OML, verify quality continuously, and control changes through configuration management. So, in the two-dimensional perspective, on the horizontal axis, we have time represented by the four main phases of the process. On the vertical axis, we have the nine core disciplines. All disciplines are represented through every phase, but each phase emphasizes different activities. This shows how RUP connects the progression of the phase over the time with the organization of work by discipline, making it a comprehensive and flexible framework for managing complex software projects. So, now the strengths and the weaknesses. RUP primary strength lies in structure adaptability. It offers unified yet flexible framework applicable to projects of various scales. Its integration with tools such as configuration management and modeling environments support consistency and traceability. The interactive nature enables early validation of architecture and risk control because of because RUP can be adjusted to project size and domain. It remains effective from enterprise level system to smaller software products. Despite these strengths, RUP is not without limitation. Its comprehensive nature can become heavily weighted if applied without customization. Maintaining detailed artifact demand experience, personal and discipline management for small teams or rapid projects. RUP may feel too formal or intensive. Additionally, its reliance on specialized tools can increase both cost and learning curve. So now we're gonna see how to apply RUP to a cyber physical system. In cyber physical system, both hardware and software work together with sensors, actors, and real-world dynamics. The RUP, with its interactive and architect-centric nature, aligns perfectly with these mixed requirements. During the elaboration phase, engineers can apply model-based design to simulate how hardware and software interacts. The verification and validation activities should also include real-time and hardware-in-the-loop testing to ensure realistic performance. By extending configuration management to physical components and maintaining a strict traceability between requirements, architectures, and tests. So, now for the summary. As we see, the rational unified process remains one of the most influential frameworks in software engineering. Its balance between structured phases and interactive cycles provides a controlled yet flexible path for development. By combining RUP with system engineering principles, especially for cyber physical system organization, can achieve higher reliability and safety. As Crucian emphasized, RUP is not static, it evolves continually, reflecting modern best practice in modern risk management and quality assurance.